In this video, you're going to learn about variable scope in JavaScript. The scope of a variable defines where it's accessible in your program based off of where it was created. So just because we create a variable in one place in our program doesn't mean it's going to be accessible everywhere else in the script. We're actually going to kick off this lesson by exploring a situation where variable scope is going to prevent our application from working as expected. Because so far, we really haven't run into any issues with scope in JavaScript. So we're going to start off with a broken example, and that's going to segue us right into the rules that surround scope in this language. So let's kick things off by creating a new file in the basics directory. One of the last files we'll be adding in here, scope.js, and we're going to kick things off with a super simple example. Let's go ahead and make a variable called var1, and I'm going to set it equal to the string var1, just to keep things easy to track. Now down below the variable, what we're going to do is make an if statement. So if condition code to run, and in the condition, we are going to type out the Boolean true. So we're creating an if statement that always executes. This isn't particularly useful in a real world program, but for our example, I want to make sure the if statement always runs. So I'm just going to toss true right in there. Inside of the if statement's code block, what we're going to do is use console.log to print out the value of var1 at this point in time. Then we're going to save the file and run the program to see what we get. Over here, I'm going to execute it, node scope.js. When I run the script, what happens? Well, what happens is exactly what you might expect to happen. We print out the value for var1. The value for var1 is the string var1. That is exactly what we see over here. So far, no issues based off of how we might think this program would work. Now we're going to take things a step further. Right here, after console.log, we're going to make var2. Let var2 equal the string var2, and then down below, outside of the if statement, we are going to use console.log to print var2. So if we run through this script, we create var1. This code always runs. We print var1, which we already created. We then create var2. The if statement ends, and we print var2, which we already created. So let's save scope.js and rerun the program from the terminal and see what we get. When I rerun the script, what do we get? We get a JavaScript error. The error is coming from line 8 of scope.js. That is exactly where we console.log var2, right here. And the actual error message is var2 is not defined. So clearly, for some reason, we're not able to access var2 right here on line 8, even though it's defined just 3 lines earlier. Now, we could even take things one step further and see what happens if I add a second console.log of var2 right here inside of the if statement. I'm going to save the program, use clear to clear the terminal output, and then use node scope.js to rerun the script. We get var1 as expected from line 4. We also get var2 from line 6, and we're still getting that error related to the console.log down below. So it's not like we didn't define this variable correctly. We're able to access it, and we have the exact same statement here and here, so why would one work when the other wouldn't? Well, let's go ahead and explore these scoping rules, and this will all make a lot of sense. Up above, I'm going to add a quick note. JavaScript uses lexical scoping. This is sometimes referred to as static scoping, and this is the idea that a variable defined in one part of your program might not be accessible everywhere else in your program, and that's exactly what we're seeing here. The context in which the variable is defined and used comes into play. When we're looking at our program, the thing we want to pay attention to when it comes to scoping is the code blocks in our script. So the only thing we have right now that creates a code block is the if statement. There are other structures in the language that'll also create code blocks, but we'll get to those later. The code block is right here, what we put inside of curly braces. So these 3 lines of code are inside of that code block. Now, how do code blocks play into scope? Well, there are 2 types of scope. The first type we have is global scope, and the second type we have is local scope. So what is global scope? Global scope contains all of the things defined outside of all code blocks. So let's go ahead and use this definition of global scope to analyze our program. defined outside of all code blocks. The only code block we have is this. What's defined outside of what I have highlighted? var1. So the only global variable we have is var1. We'll talk about exactly what it means to be a global variable in just a second. Now with local scope, we have a different definition. These are things defined inside a code block. So let's go ahead and analyze this program again. We have one code block. What's defined inside of this code block? var2. So var2 would be considered a local variable. Now this creates a scope hierarchy. So let's go ahead and add a few more comments to break down the hierarchy of this little script. And that's going to make it really clear why we can access var1 in the if statement and why we can't access var2 outside of the if statement. So in all of our scripts, as I mentioned, we have a global scope. This is always going to exist. If we go back to our simple examples like hello world, there is no code block here. So we only have a global scope. Now the global scope in this program's case contains just one variable, and I'm just going to list those out in parentheses, var1. If I created a second one, I could add it on right here, but this program just has one. Now on the next line, I'm going to indent 2 spaces, and we are going to talk about the one local scope we have. This local scope has a single variable, var2. So this would be the scope diagram for the script we have down below. Here's the one rule that's going to put all of this together. Right here, in a scope, you can access variables defined in that scope or in any parent/ancestor scope. So what does that mean for us in this application? Well, let's go ahead and break things down. We have our local scope. So what variables can we access? We can access any variable defined in this scope, var1, or in any parent ancestor scope. Well, in our little scope tree, the global scope is at the root. It has no parents or ancestors, so there's nothing else. In the global scope, we can only access var1. In the local scope, we can apply the same rules. I can access any variables defined in that scope, var2, or in any parent ancestor scope. In this case, we do have a parent scope. It's the global scope, which means inside of this local scope, we have access to var2 and we have access to var1. So that explains why we can access var1 and var2 right here and why we can't access var2 down below. var2 is not accessible in the global scope because at no point does the global scope define it or does any parent of the global scope define it. Now let's go ahead and make this slightly more complex and take a look at a more real-world global scope, local scope tree. Right here, we're just going to add another if statement into the mix. If true, and then we're going to define a third variable. Let var3 equal the string var3, and with this program in place, we can now adjust the scope tree. Alongside of our existing local scope, we're going to add another local scope for our new code block. What's defined inside of that code block? Well, right here, we just have var3. So now we have 3 scopes. Global scope can still only access var1. This local scope can still only access var1 and var2. The new local scope can only access var1 and var3. You'll notice that these local scopes are not sharing their variable values. This is not a child of this. They are siblings. They're at the same level. Both of them have a single parent, the global scope. That is why the only thing each of these can access is either their own variable or something defined in the global scope. Let's add just one more if statement into the mix. Right here, in my if statement, I'm going to add another if statement. If true, and then I'll say let var4 equal var4. Now, what might this look like? Well, we can see that by adjusting the scope tree above. Now, nested in this local scope, we have a new local scope. So right here, I'm going to add a new line. I'm going to indent by 2 to visualize this tree structure. A new local scope. What do we have defined inside of there? var4. Now, this local scope has access to var4 and anything defined in a parent or ancestor, which is var2 and var1. This is something a little more real world, like the programs that we're going to actually be creating. Don't worry about memorizing every single rule of scoping just yet. It is important to know, though, that there are rules surrounding it. When you create a program, the context in which you define and use variables plays an important role in whether or not they're actually accessible. I have a couple of more things to say about scope, and I also have some scope-based challenges for you, but we're going to go ahead and do that in the next video. The topic of scope can be a little dense, so I'm going to break this up into two parts. This was part one, where we explored some of the basic vocab and rules surrounding scope. In the next one, we're going to take a look at a couple of edge cases related to it, and it'll be your job to generate some scope trees for some sample programs that I provide. I'm real excited to get to that, so let's go ahead and jump right into the next one.